Good afternoon, Jan.
Michael, good afternoon.
How's it going, sir?
Good, good. I I see you with some delay between the picture
Oh,
and the sound. Yeah, now
hmm.
now it's okay.
All
Now it's
right.
okay.
Yeah. Eventual consistency. That's what we strive for here at historical modeling.
Yeah. So how was Thanksgiving?
Yeah, it was quite a busy Thanksgiving. Yeah, unexpectedly had a whole bunch of family at the house. We were planning on hosting dinner, so we were planning on having everybody here for Thursday. But um, my my grandparents have recently moved here from Florida, um, and um, and a couple of things happened, and they needed they needed to be more centrally located, so they ended up at our house, and then my parents they had they had gone to London, and then took a cruise back to the States, and so they were getting back that week. And since my grandparents were already here at my house, and we picked them up at the airport, they just said, well, let's just stay here for a bit, and so had them here. Um, yeah, it was really good to have to have that much family around. I really enjoyed
It was
it.
a lot of generations together.
Yes, yes, indeed.
Yeah. No, over here there is no really Thanksgiving.
Hmm.
Uh, since a couple of years we do have Black Friday, but Black Friday is more like promotions in the shops.
Yeah.
But it's a commercial thing. But
Hmm. Yeah,
further
and
than
then
that, we don't really.
yeah, and you don't take advantage of the Black Friday sales because you know that there's going to be a Cyber Monday sale, and then don't worry about that one because they're going to say, oh, it's extended. And it's like, nah.
Yeah. Oh, it's amazing that that came up just in 5 years' time.
Hmm.
Before there was nothing like Black Friday,
Mm.
and now I think it has to do with all the with internet.
Yeah, I
Um,
mean that's where the Cyber Monday term came from. Is the yeah? So Black Friday being the Friday that presumably stores have been operating in the red all year long, and then they finally make it to the black on Friday after Thanksgiving. So, that sounds kind of dubious, but if you're really running a business that way, it sounds a bit risky. Um, but yeah, I've got some FTX tokens for you. But yeah, then the whole Cyber Monday thing started when the internet was brand new and people only had access to the internet at work, and so they would go into work on Monday after Thanksgiving and go shopping from their work computers, um,
yeah.
which was probably a true story for the first year, maybe. But yeah,
Now everybody has internet.
yeah.
Almost everybody. Good. So over here, um, it was quite busy as well.
Hmm.
I did manage to make some time to continue on Jinaga.
Excellent, excellent.
Um, no white smoke yet, but
Hmm.
getting closer and closer. Um, and yeah, I'm getting sometimes
Excellent.
stupid things where I say, okay, what does that structure in TypeScript really means? How do I translate that to C sharp? What is the best structure?
Hmm.
It goes slowly, but at least that way I learn something.
Okay, yeah. Do you have something to demonstrate today?
Uh, not really, not
Okay.
really. The first test is not working yet, so
Okay. Yeah, I
I
was
would.
going to add that to the agenda. I've got a few things on the agenda. From last time, I did not get a chance to show variadic types
Yeah.
um, and queries using the specification, the new specification language in Jinaga.JS. Um, and actually, over these last couple of weeks, I have had a little bit of time to finish that out and make the in-memory queries work. So I've got some of that to show. But then I've also done a bit of renaming on the specification types in Jinaga.js. So some of the things that you brought up a couple of weeks ago, where it's like we're using 2 or 3 different names for the same concept. Let's just kind of collapse it down. Um, And so I actually do have a diagram that I just started because I hand wrote a diagram while working on this renaming to make sure that everything was consistent with the rest of the model. And so, you know what? I really want to show this diagram, but yeah, you can't read it. It's all handwritten. So I do have that in the works as well, so we can go over those things.
You had some medical ambitions.
Yes, well, yeah, that is true.
No, somebody with such an handwriting that you cannot read, they should be in medical.
Yeah.
Yeah.
Yeah, I can actually. I'll go ahead and show the handwritten version so you can see just how bad that is. Okay. And then we're going to the Remarkable app. And I need to open that in a new window. There we go. All right. So, oops. Let's see. That's the one I wanted. And
I saw it for a moment, but it's gone.
There we go. Okay. So I think that is going out on the share as well.
You would be a good doctor.
Yeah.
On the handwriting side.
Yep. Yeah, so I had to really think about this one right here. What was I writing there? Funny thing is, on the actual Remarkable tablet itself, this is a lot more readable. But it's still pretty raw. So I've been translating that to this.
Okay.
So yeah, I've really gotten to enjoy Lucid Spark. So I like its collaboration mechanisms pretty well. It's fast, and it's easy to learn how to just drop sticky notes and then move up from there. And actually, you know what my favorite? This is a bit off topic, but my absolute favorite thing is the way that that it handles. I'll go ahead and do an elbow connector. The way that it handles connectors is great. Actually, no, I'll do a straight line connector because that really demonstrates what's so awesome about them. Okay, so I want to connect this object. Oh, don't do that to me. Oh, wow. Okay, for some reason it's not working. Let me try it with a couple of rectangles. All right. Okay, yeah, just for some reason it doesn't like to do that with the database records. I've never actually tried that with the database record, but yeah, in a lot of tools, it will just find the closest points between these two objects and connect those. Or in PowerPoint, it's even worse because you connect the end to one of the 8 handles around the object. And it sticks to that handle no matter if you change the orientation or not. And so I always in PowerPoint will go center to center and then drag to where the line intersects. And Lucid Spark just does that automatically. That's just the intersection between the line joining the two centers. It's like, that's exactly what people want. Why would you do anything different? That's perfect. Anyway.
So this Lucid Spark is something that you can share over the internet as well?
Yes, indeed. So
it's like what we did with Excalibur before,
right.
A few times. Yeah.
Yeah. So yeah, this if you so I've purchased a subscription, which means that now I can share a link with somebody who doesn't even have a Lucid login. So just anonymous share, and so I can turn that on, share that link, and then when we're done collaborating, turn it off. That way, I know that nobody can't modify it again. with the free version, you can share the link, but it has to be somebody who has a Lucid Spark account, and then you've got a limited number of documents. And so I was like, you know what, this one's useful enough, I will pay for it. So
anyway, it's nice. It's a nice diagram.
Yeah. So this portion has been sponsored. No, it has not. So the diagram we're looking at here is the we'll call this Jinaga specification. Okay. So all right. To kind of start things off, I've got a couple of free-floating types, label and row, because they're used as value objects. So I didn't really want to represent them as entities that have relationships to them. So they're just kind of floating down here, but you'll see that when they're used as values, they're described inside of the fields. So a label is something that has a name and a type. So if you remember the diagram of a Jinaga model or a historical model, you've got different types within that model. A label is basically when you just put your finger on a few of them, and you say these are the points within this graph that I'm interested in, and I'm going to describe the relationships among those points, and that's how you build a specification. Yeah. Not row, roll. Yes, there we go. Yeah, I don't think my handwriting was so bad that I probably just mistyped it. Okay, so and then a role is within a specification as you're describing those relationships. That is one of the one of the jumps from successor to predecessor, and so you can use those roles. You always use the roles from predecessor to successor, but you attack a common ancestor from both sides, and that's what ends up at a path condition. But starting at the top, a specification has a set of givens, and these are labels, so they've got name and type. And that's the thing that appears inside of the parentheses when you're writing it out using the specification language. And then it's got a bunch of matches and one projection. So the matches, that's where you say, here's an unknown, which is a labeled thing. You give it a name and a type. And then in the specification language, you use square brackets to give it a collection of conditions. So those conditions can either be path conditions or existential conditions. So path condition, that unknown is always on the left. And then you have a bunch of roles from the left, and that's what the arrow indicates. So so starting from that unknown arrow, and then the name of the role, and then colon the type of the role. So name and type up here inside a role. One of the things that I did to rename is I used to call that declaring type and target type. Now it's just successor type, predecessor type, because role is always in that direction.
Okay.
Yeah.
That's more clear.
Yeah. So you've got a bunch of roles on the left that take you from the unknown up to the common ancestor. And then the label on the right, that type is not a label. That type is string. The label has already been declared as either a given or an unknown somewhere else in the graph. So you're just identifying which label you're talking about. And I think I used to call that identifier. Or at least in some places. I think here I called it label, right? But some other places I called it identifier, and that was like, it's a label. That's what we're talking about.
I wrote it down here as label.
Mm-hmm.
Label right. Type string.
Yeah, I think I had it correct here, but there was, maybe it was just one of the functions that did the traversal. It called it identifier while I was doing that. I don't know. But I've fixed that. It is called label everywhere now. And so now you've got that path condition that is from an unknown up to a common ancestor, and from an already existing label up to a common ancestor, and that defines that path that gets you from one label to another. And so yeah, that means, you know, because it's shaped like that, you can't go down to a successor and then back up to another predecessor. You basically have to label all of the valleys, and that's an important thing when it comes to actually computing the inverse, knowing that you've got everything that you need. And then you've got an existential condition, which is just, are we talking about it exists or not exists? And then a bunch of matches. So existential condition, you have the E or the not E, and then curly braces and a bunch of matches inside of there. And so that is all the part that appears before the double arrow at the bottom. After the double arrow, now you've got the projection. And this is where I really cleaned up the hierarchy. So you've got two kinds of projections. A composite projection, that's where you have the braces, and then you've got a bunch of names. Or a singular projection, and that's where you have no braces, you're just going to project to one singular value. So that singular can be a specific field. So which label are we pulling that field from, and then what's the actual name of that field? It can be a projection of an entire fact. So which label are we pulling that fact from? And then it can just be the hash of the fact. So you use the little hash symbol in front of that label name. So those are the different singular projections. A composite projection is made up of components. So we have a collection of components. Here, name was confusingly spread throughout the different projection types, and I just had this as an array. And that was really hard to map out and to understand what's going on. And sometimes you had names that didn't belong, and I had two different types, one that had a name and one that didn't have a name. It was just, so much easier to just say, okay, a composite has components, components have names, and a component projection. So now a component projection can be a singular projection, any of those things that we just talked about, or it can be a specification projection. And specification projection is just simply a collection of matches and its own projection. So then it just continues down recursively.
These modifications, they are in a separate branch, or you already merged them?
They are in the produce specification branch. So this is the branch where I started implementing this link-like syntax in JavaScript, and there was so much there was so much about this that would have to change if I completed this work on the old specification types, but then had the renaming on a different branch. So I was like, okay, in order to avoid a future merge conflict, I'll just go ahead and continue that renaming in this branch. So it's becoming a much larger branch than I intended, but I think what I will do is, well, got a couple of options. Either I will merge this branch now that I've got all of the queries working, and then continue on to inverses. What's the other feature? Well, inverses are the big one. Or I'll finish out inverses on this branch before doing the merge. Yeah, I've already merged main back into this one, so all of the the updates and stuff that I've taken on main now this branch has. So there's really no disadvantage to merging at this point. So I'll probably go ahead and do that. So yeah, if you take a look at let's see, let me go into here, and by way of here, go into specification of, and then specification. So yeah, specification of is the generic wrapper around all of this stuff. And this is actually a good segue into multiple parameter lists. So I put a generic parameter around everything, and so here's the non-generic specification, so that you get all of the great type checking in TypeScript. And you know that if I write a specification, let's go to one that's a lot more exciting. Yeah, like this one here. Yeah, this is where we're doing a composite projection. So given a company, match company, and then you also get a fact repository. So looking a lot like the .NET version now. Give me facts of type office, and join office company to company. So you're approaching company from two sides, but in one leg of that approach, you're just staying there. And then select from each of those offices the object having identifier being the office identifier and company being the company identifier. So you're able to use both of those labels inside of that projection. This one because you just gained that label, but that one because it was added to your Lambda even further up. So you've got closure as you go into each of these arrow functions. Excuse me. So so that is computed to be a specification of object having identifier string and company string. So it's able to compute from that that description of the specification. It's able to infer the type of that specification. And that way, when you do a j.query on that specification starting at a particular company, it knows that the result is an array of identifier company objects. So that type inference is working pretty well. Mm-hmm. And when you now do a child projection, so yeah, so this one just does a so here employees is a specification projection. So we've got matches inside of that specification projection. That's a match on employee with the path condition of employee office equals office. The projection that it comes up with is just a fact projection. So it's just going to return that employee fact because I don't have a .select after that. And so that computes the type identifier and employee array. So so it knows that it's going to give you back a collection of employees. And so that just carries through to the result. And I know that within this array of results, each identifier is now coupled with an array of employees. And I've got that that grouping already set up for me. So right here, in order to make this test pass, I couldn't just have this set of employee facts be equal to the employee facts that I had coming in here. Wait, where did they come from? Oh, right here. Yeah. So I've got employee and other employee. These are some input facts that I declared up here. And they're not equal because they are not the same instance of the object. They get serialized, put into the repository, you run the specification, you deserialize them, you get a different object out.
Does they have another public key?
They have the same public key. It's just a different JavaScript instance. Yeah, so you get back employee and other employee, and yeah, these two facts have different public keys. That makes them distinct facts. But this particular instance of employee is not the same instance that you get back when you load that fact from the repository. Truth be told, the object that you get back when you load from the repository is not even an instance of this class. It doesn't share that prototype in JavaScript. But I still kind of fib to you and tell you that it is, so that you can access all of its fields. But that means that you can't define new operations on a prototype. You can't just define new methods on that class and then expect to use those methods when you get your results back.
Yep.
So far has not been a problem, but if that ever does end up being a problem, then I'll say, okay, I'll deserialize the object, I'll set the prototype, and then I'll give it back to you. So yeah, what I've done here then is, so I'm computing the hash of each of those employee facts, and then comparing that to the hashes of the originals. So the hashes should be the same, and that's how I get that to pass. So the test looks a bit more complicated than it needs to be. And the real fun thing about this was, after I wrote that test, I was like, okay, well, I can simplify this test if I do the j.hash inside of the specification. And then, of course, as I would have expected, that test failed because it didn't know how to take a j.hash and give me back a hash projection. So before this, the only way that you could get a hash projection is to actually parse a specification, the specification language, and look for the octothorpe. And when you find the hash symbol, then you say, okay, that's a hash projection. But there was no way to get that from the link-like specification language, so I said, let me just create a new branch, try this out, and if I can't make this work, then I'll back it out. But yeah, as it happened, I just followed the exceptions as they were thrown and said, okay, what's the most intelligent thing to do here? Okay, let's do that. And then what comes next? And then after like 3 or 4 exceptions, it just worked. It's like, oh goodness. So that was pretty fun. So it ended up with things like here where I do this, lookup hash is just caching, and I said I don't want to go down the cache route and rely on that. Instead, let's just look at what dehydrate does, and it goes through this this dehydration method, and it's like, okay, I'm finding all of the fields, and it's like, okay, this isn't quite working out for me. But then where did it where was it that it actually ended up working out? I think I found that I could go just one level up. Yeah, so right here, when I'm traversing the lambda that's passed in to find all of the projections inside of it, then here I can do a get payload on this this definition that comes in, if I determine that it is a label, But if not, then right here. Oh, wait a minute, where did it go? Yeah, it actually is part of the payload. How did that? Yeah, you know, now that that I'm going back through this, I can't remember how I made that work. Payload type. Okay, yeah. So get payload. So what's happening here is that this label actually refers to a proxy. So a proxy in JavaScript is an object that that you can define events on, and then whenever something tries to access different fields of that proxy, then your events get hit. And it's called a proxy because by default it has a another object behind it, and then if you don't implement the event, then it's just going to pass through to that other object. So it's kind of putting a a wrapper around that inner object. So here I cast it to any in order to get rid of that label of t, which is helpful for type inference, but it's like, okay, I know it's not actually a label of t, so I'm gonna cast that away. And then I use this identity symbol in order to get the payload out of that proxy. So if I've got a join condition, then that is going to take a couple of payloads that can either be facts, fields, or hashes. Hey, that looks familiar. Facts, fields, or hashes. Then it's going to say, okay, I'm trying to do a join between these two things. What does that actually look like? And do some checking, and can't join on fields. You can't join on hashes, but you can join on facts, and so that produces a path condition. And out that comes. But yeah, the actual payloads are a fact payload. So it collects all the information that kind of led down to that fact payload. What root label did you start with? What are all the roles that you appended to that root? And then what's the type that you currently ended up with? And that way it can dig through here. And the thing is, yeah, this is how that all worked out. Is if you are on a fact proxy and you ask for the hash of that fact using this hash symbol. So identity will give you back the payload. That'll give you back this this object, but hash symbol will give you back a hash proxy, and that's just another proxy that just has the hash payload. It says, okay, what is the label that you're getting the hash of? That's it. That's all you can do. So yeah, that was the trick that made that all work, and that's because way back up here, let me go to where hash symbol is defined. So that's a symbol, and right here when you dehydrate, yeah, it's right here when you look up a hash. You check to see, does that fact already have a hash built into it? So, so I originally did that as an optimization, because in order to compute the hash of a fact, you have to visit all of its predecessors and all their predecessors, and so you do the transitive closure. And if you're naive about it, and you've got these join where the graph rejoins. Has some common predecessors, then you're going to be computing those hashes multiple times. And then furthermore, you're going to have a lot of common ancestors at the top, and a lot of it's going to spread out at the bottom. And so every time you compute the hash, you're going to recompute all these hashes up here. So it's like, okay, let's just when I compute a hash, let's stick it into that instance using this symbol. So yeah, I just noticed that it's like, hey, I can take advantage of that if it asks for that symbol in one of these proxies. Then I can just give you back that hash proxy, because I've just called j.hash inside of there it is, inside of a select. So that all just kind of worked out, and then after a little bit it was like, oh, that actually does exactly what I want.
Amazing. Another piece of complicated code.
Yeah. And as I one of the things that I use hashes for quite a bit is in React, you need to have keys associated with components if those components appear in a collection. That way, it's able to see that I've removed something from the middle of a list, or I'm inserting into the middle of the list, and it's able to do the minimum operations on the DOM. But and so I'm computing hashes inside of React Query all the time, or not React Query, Jinaga React all the time. And so it's like, okay, this now builds that in, and it's so I should be able to take Jinaga React and just really boil it down and use these projections to do most of the heavy lifting. And then the only thing that I'll be left with is every time I've got a sub-select, I just need to offer you a way to project that collection through a list of components. And you'll have to provide me a way of computing the hash. So you just provide that lambda, and then the component, and then everything else that you put in here are props to that component. So that's going to get much simpler.
Yeah, you write it much faster than I can decipher it.
Yeah, I find that I'm having every once in a while I have these things that fall out, like I was describing here. I mean, it looks really complicated when you look at it from, and in fact, I couldn't even remember what all the different steps were, and we had to find what those steps were. But at the time, it's like, all right, take what's already there as a given, and then just what would the next step have to be in order to accomplish this goal. So as long as the goals that you're trying to accomplish are part of a cohesive theory, then there's a high probability that the implementation will fall out, given what you already have is consistent with that theory. And so when things like this happen, that gives me confidence that this implementation is really getting close to a cohesive implementation of a consistent theory.
Yeah.
So I was pretty happy about that.
Mm-hmm. The good thing is that it you get further and you don't get stuck somewhere, because that would be another possibility, that at the moment that you say, yeah, now I'm stuck, I missed this or that information.
Mm-hmm. Yeah. And this is one of those things that I like to. One of my favorite parts about mathematics is it's got several proofs of things that you cannot do, and it's got another set of proofs of things that you can do, but I'm not going to tell you how. So yeah. like Gödel's incompleteness theorem. You cannot have a system of axioms from which you can derive all true statements, given that those axioms are sufficient to describe something as complex as predicate calculus. So it's just a proof that this thing just cannot happen. But then on the flip side, I'm trying to think of another example, but there's a proof that such a thing exists, but we're not going to tell you how to accomplish it. Like fundamental theorem of which one is it? Fundamental theorem of algebra. Anyway, the theorem that every number can be uniquely expressed as a product of primes. So every integer has a unique prime factorization. That theorem doesn't tell you how to find that prime factorization, and in fact, that's a very difficult thing to do in some cases. But it tells you that such a thing always exists. You can't come up with a number for which you can't find the prime factors theoretically, and you can't come up with a number that has two different ways of prime factorization. It's always distinct. So anyway, how that relates to all of this is that I've done enough of the math and the reasoning through that I know that a solution exists, and I haven't yet found the solution. I haven't yet written it out in code, but I know it exists, and so I'm happy leaving that there with a throw not implemented exception and moving on and implementing something else. And that gives me confidence that I'm not going to put myself into. I'm not going to code myself into a corner. I'm not going to write something for which now this other thing doesn't have an implementation because I've stuck to the framework of the theory. So yeah, in this case, it could have been that the tools available to me in JavaScript were insufficient to make this particular syntax work. In which case, I would have just come up with a different syntax to accomplish the same thing. But as it turned out, the JavaScript wasn't preventing me from doing it, and so I could do it.
The syntax looks quite similar to what we have in .NET now.
Yeah. I was really pleased with how that all came out. Yeah, the thing that really simplified that and made that work. So up here I'm describing a bunch of instances and giving the initial state of the Jinaga test instance. But in order to get to this specification syntax, I need to also have a model. And the model is described in this other file, where I'm just saying these are the different types that were declared, and these are their predecessors and their types. So this model produces a fact graph. In fact, you know what? That would be really useful to have some kind of method on model that gives you back the graph is.
That automatically generates the diagram.
Yeah, because all the information's there.
Yeah, in fact, it's very compact.
Mm-hmm. Mm-hmm. Yeah, and this uses type inference as well. So, so I know that this string can only be office type or user because those are the fields of employee it is by more than convention. I always have a property called type. So, you know what? I could actually, let me go ahead and make a note of this. I can remove the type property from type inference. And I know that is used inside a predecessor. I'll look to see if there are any other instances where I'm doing that. I think that's the only one. You know what? Label, yeah. Yeah, label could do that too. So when I come back here and I say join office dots, I've got type showing up in the list here, but TypeScript is powerful enough that I can remove one of those fields because office is actually a label of type office, not an office itself. Yeah, that's going to make things a bit more clear. But yeah, I've got the type inference there, and then once I select, I could even remove the fields. Yes. Predecessor. And yeah, why not join? Yeah, I can do that in both cases. Okay. So yeah, once I've got the that predecessor selected, office, then it further constrains this. It's kind of hard to get it to tell me if I'm not typing it out. But it knows that this has to be a fact constructor of office because that's the that's the field of the JavaScript type that I used. So yeah, if I'm in the process of doing this, I've got that predecessor, and then that user type or office. So I say dot user. We've got Copilot. Copilot so easily learned this. It's just crazy. But then I know that this has to be selected from all of the different types available, but the IntelliSense says, I already know this has got to be a fact constructor of type user. So no matter what I choose, it's going to say, nope, that's not a fact constructor of user. I have to choose the right thing in order to make that pass. So I've got this declaration of the model that survives compilation and contains all of the type information that I need from TypeScript.
Yeah.
So cool stuff. And yeah, so the final thing that I wanted to show was variadic. There it is.
This is already pretty amazing.
Yeah. when I discovered how to do this, I was like, oh goodness, TypeScript is so amazing. Okay, so in this case, I wanted to say, given a company and a user, I want to match company user and then my fact repository. So yep, there's my fact repository, but it knows company is the first type that I listed there, and user is that second. And it wraps those in label. So it knows that these aren't the actual company and user, they're labels of those things. Just like here, after facts of type, it creates a new label of employee. So, so that means match is variadic in nature. So we get a definition that is some kind of an arrow function, some kind of a lambda, and its parameters are declared by this this generic type match parameters, and that gives me back a specification of t with a specification result of u. But we're focusing right now on this guy. One way to think about type declarations in TypeScript is to really think about them as functions. So this generic type declaration is really a type function. It maps from one input type t to an output type. So once I started thinking about these as type functions, it really just made it possible to compose, to to put together just the right features of the language to get what I wanted. Prior to that, it was just this arcane language that I just have to Google for specifically the thing I'm trying to do, and then copy that syntax and change the names. And that's no way to build something up like this. But now that I understand these as functions, I can do very precisely what I want to do. So, what are you doing? Don't eat plastic. Silly cat. Okay, so I want the match parameters of type T. So one of the most powerful features in this type function syntax is the extends keyword combined with this conditional type operation. So it looks just like the ternary operator, but it's specifically for types. And so this gives you a condition, and if T extends this type here, then that's what you give back. Otherwise, you give back something else. So I'm using that here to do some pattern matching. So is T an array having at least one element in it? If so, go ahead and infer the first element, and then you just give me back the rest, which could be an empty array if it only had one element in it. And so then I use this recursively. I'm going to give you back an array where I've wrapped the first inside of this label construct, and then recursively call match parameters with the rest, until finally I have an empty array in which now I just give you back an array with fact repository. So what that is going to do is, let's just say I want a type, call it Q equals match parameters, and now I'm going to give you an array. Okay, stop helping me, thank you. And we'll just do string, number, and Boolean. Just a few types. And there we go. That's what I pass into match number. And so Q comes out with label of, oh, wait a minute. Oh, okay. Label is doing other stuff for me. So let me have some types that I can play with. Type A, type B, and type C. I have to make these distinct, but make them all objects. Yeah, just to be complete. Okay. All right. So now we've got A, B, and C, and so Q is going to give me back an array of types: label A, label B, label C, and then stick fact repository on the end. So by using match parameters as a function here over some type T, I am able to then spread those parameters into an arrow function. So I basically declared using a function the parameters of some arbitrary length list of this this particular lambda. So this T is the key that unlocks all of that. What T makes that happen is I say given company user. So that is really a given of array type company and type user. And it's able to infer that because given is declared right here on model, and T, it says, okay, I'm going to constrain that to a set of fact constructors, but you're going to infer from the parameters that that come into this given function what actually T is. And since I'm using the spread operator, this is basically, the spread operator can work in either direction. It can spread an array out to a list of parameters, or it can collect a parameter list back into an array. So because I'm using it here, it's collecting that that list of parameters back into an array, inferring the type of that array, and by this constraint, we know that the only things that we can pass along those parameters are fact constructors. So just to round things out, a fact constructor is something that can create a new T given some arguments. So again, here's that spread operator, but here we're just saying any number of arguments and I don't care what they are. Something that can construct a T using new, so it's a constructor. And that thing also has a type with a capital T. So that matches any class that you might declare having a static type that can be converted to a string. So company as const, the type is not string, the type is the string company. It's a unit type. That's the only string that matches that particular type. So that means that string is now available to the type system. And that way when I open quotes in just the right place, and then it can list, well, these are the only types that are available. And so that one shows up there. So yeah, this allows me to infer all of the different types that are in T, run that through a function, and then give me back a set of parameters that are labels of those types plus a fact repository. And so that's how I know right here what company is and what user is. And then of course what facts is. So yeah, variadic. Variadic functions. Pretty powerful stuff.
I'm going to run that through a debugger to see what it what goes out, what goes in, and how it works exactly.
Yeah. Yeah, all of the type inference stuff that will happen before the debugger ever sees it. The part that will be interesting is like here, I'm spreading these labels that I've produced, which are proxies. We already just talked about the proxies. So I've created a bunch of proxies. I spread those out, and then I put the fact repository on the end, and pass that into this function. I have to cast away the actual type of that function so that I can call it with that that set of objects, because it doesn't actually know that a fact proxy is a label. Telling TypeScript about that would just be too much. So yeah, by that point, then you'll see it produce these objects, and then it calls the function, and all of a sudden they are parameters of that function. But yeah, following that through to then diving into each of those proxies and saying, oh, I'm now doing a dot and getting another field. Here's the field name, and look it up in the model. Okay, I know about that in the model, therefore it's a predecessor. Or I don't see it in the model, it must be a field. And then producing the next proxy. So you'll see all of that happening there.
That's what they call black belt programming.
Yeah, that's just getting the job done. Yeah, with that, you can just write the intent and let it infer everything else. So yeah, so far it's inferring the actual execution of a query. Oh yeah, so query inverses, and then the reason for query inverses in this case is that I should now be able to do a j.watch. So use those query inverses and update the observables that are coming out of j.watch. So yeah, that's the next part to implement there. But yeah, I think I will merge before I do that.
Mm-hmm. Great, great.
There we are. Cool. So that is my plan. Probably, I don't know if I'll be able to finish inverses over the week, but at the very least, I'll be able to take that diagram, finish that out, make sure that that's correct, and get that added to the README in the core Jinaga project. Now I do want to use that renaming inside of Jinaga server. In order to do that, I need to publish a new version of the core Jinaga. And that's the part that I'm a little bit reluctant to do until I have inverses working, because that means now you can, in the published version of the the thing, you can write a specification that you can only use in one way. And in fact, you can only use in memory and in tests. You can't use against Postgres. So yeah, I think I'll hold off on that until I've got a little bit more there, and then secretly I'll just do a quick join from Jinaga server to Jinaga, and then make the Postgres stuff work. Which actually, it's already working against that structure. It just needs to do that in support of j.query and j.watch against a Postgres store, but it's already converting those queries or those specifications into SQL, because that's how the specification language through Postman works.
Yeah.
It just kind of goes around everything and says, "Oh, okay, generate me this SQL and run it, and then I'll produce the results." And now it'll come through the proper channels and do that. So yeah, I'll get all that done, and then I'll publish them both at the same time.
Yeah, I will try to digest all that.
Well, that's why we record the video.
Yeah. Next week, I'm probably not there. I told you.
Yeah.
Probably. There's still a small chance that I can make it, but probably not.
Mm-hmm.
But the week after, I will definitely be back.
Okay. Yeah. In fact, I was talking with actually my current client about the history CRDT and the what CRDTs can prove, and then what history adds to that. So, and he was asking, "Oh, do you have a paper written up on that?" I said, "Well, I'm working on the paper." And I kind of talk about it, in these videos, if you want to go back and watch a whole bunch of them. But maybe what I'll do, if you're not there, is I'll just take an hour to go over the history of CRDT and talk about the math behind it. That way, okay, there's one consistent hour of discussion on what that does.
That would be a good idea, I think. And all the information is inside there, all the math.
Yeah. Even if you are here next week, we'll do that.
Mm.
Yeah, that way
All
I've got
right.
somebody to ask questions while going through it.
Yeah, if I'm not stumped by by the presentation.
Well, that's you're a great observer proxy.
Yeah, but often like today, the code is so amazing that I will need time to digest it. So yeah, the questions are not in real time.
Mm-hmm. Well, I got to tell you, the amazing part is TypeScript. That it's like, wow, I always thought about JavaScript as so sloppy, but then what TypeScript does is it encodes the intent that people had in their minds in the first place when writing JavaScript code, and then now seeing that intent expressed as mathematical functions, it's like, oh, that wasn't sloppy at all. You know, people were thinking this way, they just didn't have a way to write it down or to prove their theorems, and then they were writing. I mean, what jQuery had to do in order to give you a single dollar function that it just expresses all of this dumb manipulation. It's just incredible, and so yeah, for who was the jQuery guy again? Oh goodness. But yeah, in order for him to come up with that, keep all of that in his head while he's writing jQuery, and for it to work well enough that the entire internet takes a dependency on his library, that actually is quite an achievement. So I'm just really happy that the compiler comes along and says, oh yeah, that thing that he was trying to do, okay, here's a formal language for it. Oh, thank you. Now I can reason through it.
Yeah. TypeScript is in fact the math layer on top of JavaScript.
Yes, it is.
Yeah.
Yeah, and that's the story I'm trying to tell in my next Pluralsight course, which is TypeScript for React Native.
Okay, so that one was for when?
Yeah, that is going to be finished sometime in December. The due date is actually December 17th. Probably not going to hit that date now, but yeah, it's coming along pretty well. It'll be out by the end of the year. Just
That's
really
something for New Year.
Yep.
Christmas and New Year. All right. I try to make it next week, but probably I will not. But then I will see the video on the history CRDT. And then in 2 weeks' time, I will surely be back.
Very good. Excellent.
Okay.
Well then, I will see you when you get back.
Okay, Michael. And meanwhile, I try to arrange everything in my brain. Okay.
All right.
See you.
All right.
Bye-bye.
Bye.